Time is a fast thing, right? You ever think about time? You can tell I think about time a lot. 1,000 minutes, about 1,000 minutes a day is what you got to do whatever you're going to do with it, right? 1,000 minutes. That's about it. I mean, if you sleep 7 or 8 hours, like I like to sleep 7 or 8 hours. Anyway, then you get about 1,000 minutes. I mean, that little hand goes around 1,000 times a day, and it's over. Anyway, so moving quick here, moving quick.
We'd reach Japan like clockwork.
Okay, so they give me this table, and they want me to figure out, is this thing exponential, linear, or neither? Exponential, this section is exponential functions. What are exponential functions? An exponential function, exponential means x in the power zone. Let's first off be really clear on that. X is in the power zone. So it's things like this. Y equals 2, well, let's say y equals 3 times 2 to the x power. Does that make sense? So it's not just things like x squared. X itself is in the power for an exponential. Not just that it has powers, but that x itself has climbed up there into the power zone. Does that make sense? That's what I really want to make clear for you. That'll be a huge deal if you go on into calculus for the derivatives. This kind of a function has a whole different set of rules for how you do the derivative than this kind of a function. So you really want to think of them in two totally different categories. This is just a polynomial. We just call that polynomial. It's got powers, yes, so what? But this has got x climbed up into the power zone. That's mighty. These functions will do big things fast, and they're called exponential functions. It means x itself is in the power zone. Okay, so what? So what does it have to do with this table thing? Well, generally, let me give you how to do it. This is an xy. Remember, f of x is just y. This is an xy table. They're basically giving me some dots from an xy table. And they're saying, hey, what kind of function did that come from? They're playing name that function game here. So they're saying, is it exponential? Or is it linear? Or maybe it's neither. How do I determine that? Well, look at what these numbers are doing. Are they adding, if they're adding, subtracting the same number each time, if they're doing that, then it's linear. Meaning it's y equals mx plus b. That's the first thing. If they are, instead of that, if they are multiplying, dividing the same number each time, then it's exponential. Exponential is what that means, which means you have y equals a times b to the x. And I'll show you how to find the particulars about that. But that's just the first thing to discern. So look over here and go, let me see, 3. If you add 2, that's 5. If you add 2 again, no, that's not 10. So it's not adding the same number every time. It's not linear. Right? Linear, you got to add the same number. That's the slope. Linear, as x goes over, y goes up, same amount every time. That's what a line does. It adds the same amount to the y value every time. It's called the slope. So this is not linear. This is not going up the same amount every time. But is it multiplying the same number? Like 5 times 2 is 10. Times 2 again would not be 15. So it's not exponential either. So this one's neither. It's neither exponential nor linear. It's not adding the same number every time. It's not multiplying by the same number. It's just something else, something weird. But it's not linear, not exponential. All right, let's look over here. What's happening for the y values from number to number? Is it adding the same number every time or multiplying the same number every time? It's going times what? Times 3 every time, isn't it? Right? Times 3. Times 3, right? 1 times 3 is 3. 3 times 3 is 9. 3, just times 3 every time, even 1/3. Times 3 is 1. So it's multiplying by 3 every time. So it is exponential. So first off, yeah, it's exponential, but now they want to know, okay, what is that exponential function? Well, I gave you the general setup. It's a times b to the x. That's what you want to put in your 3x5 card, that's the general form of an exponential, but we got to find the a and the b now. How do you find the A? The A is whatever is across from x equals 0 in the table. There's your A. 1. It's whatever's across from x equals 0. I'll tell you why in a minute, but let's first just get it. So A is 1. And what's the B? The B is the number you're multiplying by every time, which is 3. That's your B. Here's our formula. And you don't really need the 1. 1 times 3 to the x, that's really just 3 to the x, isn't it? Everybody see that? Why is that A thing whatever's across from x equals 0? Well, because if you plug in, if you're making the table, you know, and you plug in x equals 0 here for x, what is 3 to the 0 power? What's anything to the 0 power? Do you remember? 1. Anything to the 0 power is 1. So this part's just all going to become a big 1. So y will just equal whatever's here. That's why. Because it makes the power part just become 1 when you put in x is 0. So whatever's across from that is the A. So that's why that works. Well, we got 2 problems done. All right. We'll stop.